Well, now we will prepare, the aldehydes and ketones from the fifth method, that is from alkynes. Well, alkynes means, let us take alkyne U, basically, that is a triple bond, right? Suppose, I have acetylene. This is acetylene, or we can say this is acetylene, or we can say ethine. And when it reacts with water, HOH or H2O, in the presence of 30% of sulfuric acid or HgSO4, 30% of sulfuric acid or HgSO4, what happens here? Here, first of all, you see the CH2 alcohol is formed. Here alcohol is obtained, and if it tautomerizes, on tautomerization it gives acetaldehyde, CH3CHO. Yeah, that means when acetylene reacts with water molecule in the presence of 30% of sulfuric acid with HgSO4, then first of all one alcohol is obtained, and if that alcohol gets tautomerized, then acetaldehyde results. So the reaction for the formation of acetaldehyde from alkyne is given. But if we will take if we will take propine, that means 3C is there, so this is propine. So if we will take propine, the same you will take the sulfuric acid or HgSO4, right? If you will take the propine, what generally happens here? CH3 single bond C, double bond CH2, and here it is OH. So first of all the alcohol is obtained, and on tautomerization, it gives CH3, CH3, C double bond O. This is acetone. Yes, and it is very simple to understand that when the propine reacts with water molecule in the presence of sulfuric acid or HgSO4, then first of all one alcohol is obtained, and if that alcohol gets tautomerized, then acetone is obtained. That means from the alkyne both the aldehydes and ketones are obtained. But how? When the acetylene reacts with water, it gives acetaldehyde. Similarly, when propine reacts with water, it gives the acetone. So this is all about the fifth method, that is from alkynes, for the preparation of the aldehydes as well as the ketones. Okay, now we will move on to the sixth method, that is from Grignard's reagent. Well, if you look at the Grignard's reagent, what is the formula for Grignard's reagent? RMgX. So this is the formula for Grignard's reagent. That means where R is an alkyl group or aryl group, and Mg magnesium, and X is halogen group. It may be the chlorine, bromine, iodine, or whatever it may be, right? So how the aldehyde is prepared from the Grignard's reagent? Let us take Grignard's reagent RMgX. When it reacts with hydrogen cyanide or hydrocyanic acid, first of all it gives RCH double bond NMgX. First of all it gives the addition product. This is basically the addition product. Look at here, RCH double bond NMgX. So addition product is obtained, and if addition product followed by the acidic hydrolysis, it gives RCHO. RCHO plus MgOH magnesium hydroxy halide. So this is what here it is obtained, or ammonia is also released from it. But anyhow, the main product is aldehyde, here it is obtained. But what is this is basically the chemical reaction. Here it is Grignard's reagent. So Grignard's reagent and hydrocyanic acid. At first of all, what will happen? The addition product is obtained, and then after followed by the acidic hydrolysis, aldehyde results. So if we will if I will give you the specific example, let me give you a very brief understanding. Well, suppose CH3 Mg that we have Br, that is methyl magnesium bromide. And when this methyl magnesium bromide reacts with hydrocyanic acid, then it gives first of all the addition product, double bond NMgBr, and this is addition product followed by acidic hydrolysis. What it gives, CH3 CHO, acetaldehyde results, along with MgOH, Br, magnesium hydroxy bromide, along with ammonia molecule. Anyhow, the acetaldehyde results. So this is what the main product that we need from this reaction. That means when the methyl magnesium bromide, so this is methyl magnesium bromide. So when methyl magnesium bromide reacts with hydrocyanic acid, first of all addition product results, followed by the acidic hydrolysis. Later it gives acetaldehyde with magnesium hydroxy bromide. But using the same method, that how can we prepare the ketone? So suppose I have, the Grignard's reagent RMgX. When this RMgX reacts with RCN, that is alkyl cyanide. So here magnesium, the Grignard's reagent reacts with HCN. But here the Grignard's reagent reacts with alkyl cyanide, or we can say nitrile group, right? So what generally happens here, in the exact way, in the same way here it happens. It is NMgX, right? First of all the addition product results, and followed by the acidic hydrolysis. What happens here? Then ketone results along with magnesium hydroxy halide. So this is ketone. So if we look at, if I will give you the specific example is nothing but you put the CH3 group. Here it is. That is CH3 MgBr. CH3 CN, that is methyl cyanide. So what happens here? First of all, the addition product results, NMgBr, and followed by the acidic hydrolysis. Then it gives acetone, CH3 C double bond O, along with magnesium hydroxy bromide. So this is what the acetone is obtained by the Grignard's reagent, that is methyl magnesium bromide. So once again I just want to make you clear that when the Grignard's reagent reacts with hydrocyanic acid, then at last followed by the acidic hydrolysis, then aldehyde results. Similarly, when Grignard's reagent reacts with alkyl cyanide, first of all addition product forms, then after on acidic hydrolysis, then ketone is obtained. And this is what the specific example is also given. So what is the name of this one? Methyl magnesium bromide. Methyl magnesium bromide. And you see this is acetone is obtained. So acetone. So this is what the main product of this compound. So this is all about the sixth method where the aldehydes and ketones are formed, that is from Grignard's reagent. Now we will move on to the seventh method for the preparation of aldehydes and ketones, that is from alkenes. Well, if you look at the preparation of aldehydes and ketones from alkenes, that is by ozonolysis. When the alkene reacts with ozone means O3, right? Alkene basically it is double bond. When alkene reacts with ozone in the presence of carbon tetrachloride CCl4, first of all ozonide results. How the addition product is formed in the previous reaction, similarly first of all the ozonide forms, and if that reacts with the water molecule along with the zinc dust, then aldehyde results along with the hydrogen peroxide. So the specific example for this is also given here. So I have the specific example for you, that is 2-butene. When this 2-butene reacts with butene, because 1, 2, 3 and 4, that is 4 carbon atoms are there and it is connected with a double bond. Similarly this is 2-butene. When this 2-butene reacts with the ozone molecule, then what happens? First of all the ozonide results along with the water as well as the zinc dust, then acetaldehyde, RCHO means acetaldehyde, along with hydrogen peroxide is formed. So in this way the aldehyde is formed from this method. Similarly, how the ketones are obtained? Here it is nothing but you will just change. Look at here, we have RCH double bond CHR, but here removing that hydrogen you add another alkyl group so that the ketones are obtained here, that is R2C double bond Cr2. what happens when it reacts with ozone. When it reacts with ozone in the presence of carbon tetrachloride, you see, first of all, ozonide results. Then after, along with zinc dust, if it treats with zinc dust and the water molecule, then the ketone is obtained here, along with the hydrogen peroxide. So I have the specific example for you, that is 2,3-dimethyl-but-2-ene. So the name of this compound is 2,3-dimethyl-but-2-ene. Note down this point very carefully. And if it reacts with ozone, right, in the presence of carbon tetrachloride, ozonide is result first of all, then along with the water molecule or the zinc dust, then acetone forms along with hydrogen peroxide. So these are the various examples, the reaction along with the specific examples also given for you to understand and to make it very clear, the preparation of aldehydes and ketones from the method of, from alkanes. And now we have the last method of the preparation of aldehydes and ketones, that is from the carboxylic acids. Well, if you look at the last method, that is from monocarboxylic acid, our intention is that how the aldehydes and ketones are prepared from this monocarboxylic acid. Well, that we have, you see, monocarboxylic acid, RCOOH, this is carboxylic acid. When this carboxylic acid reacts with formic acid, in the presence of, you see, the manganese oxide at 673 Kelvin, then, this is, calcium or carboxylic acid. Carboxylic acid, and when it reacts with the formic acid in the presence of this manganese oxide 673 Kelvin, then it results RCHO along with the carbon dioxide along with the water molecule. So this is aldehyde. So if I will give you the specific example for this, so here R means CH3, right, CH3COOH, acetic acid, and when it reacts with HCOOH, that is formic acid, the same manganese oxide 673, then it results CH3CHO, acetaldehyde along with the carbon dioxide with water molecule, and here it is acetaldehyde, yeah, and here it is acetic acid, and this is formic acid. Yeah. So when acetic acid reacts with formic acid in the presence of manganese oxide at 673, then acetaldehyde results along with carbon dioxide plus water molecule. But using this method that we have prepared the aldehyde, but using this method, how can we prepare the ketone? That's what one of the most important point. If I will take both the acetic carboxylic acid, that is RCOOH and RCOOH, that is using this manganese oxide, the 673 Kelvin, then what generally happens, since two R's are there, right, so the ketone is obtained from here. It is C double bond O, carbon dioxide along with the water molecule. You can give the specific example, that is CH3COOH, the CH3COOH, a mixture of the acetic acids, and MnC, this is CH3, C double bond O, acetone, carbon dioxide with water molecule. So this is what here it is obtained, this is what called acetone. In this way the ketone is obtained from the monocarboxylic acid. Now if you will ask me, sir, what will we do if the mixture of formic acids are added? Suppose the formic acid HCOOH and HCOOH, if the formic acids are heated, the presence of this MnO at 673 Kelvin, then what generally happens, the formaldehyde results with carbon dioxide molecule along with the liberation of the water molecule. So if a mixture of formic acid takes place heated with MnO at 673 Kelvin, then formaldehyde results. If a mixture of carboxylic acid as well as the formic acid heat, it gives the aldehyde. But if a mixture of acetic acid as well as the formic acid gets heated, then acetaldehyde results. If a mixture of both the acetic acids are heated, then acetone results. So in this way the aldehydes and ketones are formed from this method, that is from monocarboxylic acids. So this is what all about the methods of the preparation of the aldehydes as well as the ketones. So that's all for today's session. Anyhow, thank you very much for watching, and if you would like to watch the next part of the video lecture, I would request you to press the bell icon over here for the latest notification. Thank you very much for watching.